Hello, nice to meet you. Now let me start with a brief introduction of who we are and what we do. Founded in 2003, VirtualBuilders is one of the leading firms in developing futuristic spatial technology of construction IT, convergence IT, and digital contents based on BIM and GIS convergent spatial technology. And recently, we're especially interested in developing and marketing our own BIM software. So today, I'd like to talk mostly about our latest developed BIM solution. For those of you who are not familiar with the concept, BIM is a generation and management process in the AEC industry, which stands for Building Information Modeling. It's a process of constructing a virtual simulation of a building which manages numerous information derived from numerous stages of building design, may it be 3D modeling, construction details, and mechanical systems. BIM is an inevitable next wave of the building design process, as many buildings today not only are designed in complex form, but also require mass data information management. Differentiating itself from the mere 3D computer modeling of the past, the true innovation of BIM comes from putting together various data and systematically managing it. Through the total integration of information, BIM not only can drastically reduce the burden of handling mass data, but eventually can extend to creating a platform that manages the entire life cycle of a building, from design through construction and even management. This is why we started the K-BIM Initiative 2 years ago. As a project issued by the Korean government to develop a world-class BIM software, VirtualBuilders were given approximately $4 million and 2 years of development time. So today, I'm thrilled to introduce our latest developments from VirtualBuilders. They are an easy-to-use modeler, a powerful checker, and an effective collaborator. A proud result of the K-BIM initiative of the past 2 years, we believe that these three solutions will be some of the most innovative BIM solutions out there, and we are calling it the ABIMO platform. While fully encompassing the effectiveness of BIM, these solutions are much easier to operate compared to other existing BIM software. It is powerful yet user-friendly. So let me start with the modeler. The ABIMO Modeler is designed to model various types of building components. With the support of Parasolid Designer, the user of the ABIMO Modeler is able to model from the very basic architectural elements to the most complex geometries. By simply choosing a building component category from the menu, the user can easily start modeling the desired structure in a three-dimensional virtual space. Modeling in the ABIMO Modeler can be roughly classified into two types. It's the linear type modeling and the planar type modeling. Linear type modeling is a type of modeling where elements are modeled through clicking start points and end points. Through defining starts and ends, and eventually defining lines, certain elements are modeled according to the direction and length of the vector. Elements modeled through the linear type modeling include walls, stairs, ducts, or pipes. Planar type modeling is executed through defining a certain outline of an area that defines the outline of the element you'd like to model. Here especially, you are automatically switched to the modifying mode, where you can edit or delete outlines before you click the apply button for it to get modeled into the actual element. Elements modeled through the planar type modeling are floor slabs, ceilings, roof, spaces, etc. Every element modeled in the ABIMO Modeler is tied to a certain level parameter. This means that each model is associated with a level, and its form, dimensions, and existence is dependent on how the level is defined. Take this column for example. In elevation, you can see that the base is constrained to a certain level, in this case level 2. On changing the base constraints, you can see that it moves to a different level. By setting a top constraint, you can also link the top of the column to a certain level as well. And of course, when deleting a level, elements that are tied to that level are deleted with. Certain elements can be loaded from the library and inserted into the project. Here's an example of loading an escalator from the library and placing it into the project. Customized elements can be modeled in the library editor by the user and loaded back to the project. This is an example of a project model from the ABIMO Modeler from scratch. You can see that all levels are showing modeled space of each story. Different elements are mapped with different materials. The main modeled elements include walls, floor slabs, columns, and beams. There are also other elements such as windows, curtain walls, stairs, and escalators, all modeled with the ABIMO Modeler. Models in the ABIMO Modeler can be displayed in different types of visibility modes, such as hidden lines, wireframe, X-ray, shaded, or realistic. And now the ABIMO Checker. The ABIMO Checker is a platform on which you can check the model project to see if it meets certain requirements, such as building regulations, area requirements, or rules for handicapped accessibility, and so on. Not only that it validates regulations, but it's also capable of checking physical conditions, such as interference between elements or connection validities. Here, I will check to see if certain elements run into certain other elements. After opening the project that I want to check, first I'll start with loading a pre-customized rule set. A rule set is a file made up of a combination of different rules for you to check on your project. In this case, I've set the parameters so that it checks the interference specifically between walls and ducts. After loading the rule set, you then click on the Check button, and the checker will automatically check the model and show the checking results on the Check Results window. By selecting the detected particular elements on the Check Results list, the elements are highlighted in the model. Checking if mechanical elements like ducts or pipes are connected to each other. This is an example of checking physical conditions of a model through a coded script. By clicking on the script editor, you are able to load Python scripts that are written to check various conditions of the model, and in this case, the connection conditions of ducts. By simply typing in the ID of the ducts you want to check into the script, it automatically will figure out the result for you. Here you can see that the result showed a true status, which means that the ducts that I've selected are connected. The fact that the ABIMO Checker can run scripted rules to check the model can show you how flexible it can accommodate to various regulations. Also, with the rule set editor, you can edit and combine different rules to create your own set of rules. So the significance of the ABIMO Checker, as you can see here, is that it's highly adjustable and can be customized to nearly any type of rule imaginable. The ABIMO Collaborator is a powerful collaboration system which lets you to share a project with multiple collaborators. After connecting to the ABIMO server, the user can create a group for the team you're working with. By assigning each individual with different levels of authority to the project, you can set up an efficient working system for multiple people to collaborate. A project can be uploaded to the ABIMO server by one of the collaborators for the other collaborators to download. Once downloaded, each collaborator can be assigned with an original color of their own, and in a modeling process, each element added by a certain collaborator can be displayed by the original color the collaborator is assigned with. Through the color coordination, different actions executed by different collaborators are visually expressed in the model to prevent confusion and to bring clarity to the collaboration process. Changes in the model and other updated information of the project is sent and received with the collaborating group so that you don't have to go through the process of re-downloading the entire project again. Also, certain elements in the project can be locked or reserved through the server. This prevents conflicts that can occur when multiple people are working on the same element. There are also small perks in the ABIMO Collaborator system as well. This integrated messenger, for example, can be used as a general communication system among the collaboration group. So today, I've had the privilege of introducing the ABIMO Modeler, the ABIMO Checker, and ABIMO Collaborator to you. But there's another thing I'd like to introduce. In fact, it's one of the most important things about our solutions I'd like to introduce today. It is the fact that the ABIMO Modeler, the ABIMO Checker, and ABIMO Collaborator is actually one thing. The Modeler, Checker, and Collaborator is all integrated into a single platform called ABIMO. This is to provide you with a totally synthesized experience of an integrated modeling environment. For instance, in the ABIMO environment, there is no need for you to export your project out to other platforms to check your model. It is all done within a same window. Here you can see that I am loading the Checker platform on the same window that I was modeling. After checking certain rules, and when errors are detected, I can simply edit my model in the same window and check again with the checker to see if the error has been fixed. Having multiple solutions in a single platform does not only save your time and effort, but also saves the inevitable data loss that happens during the process of converting a file into different file formats. We believe that the integrated environment of ABIMO will drastically improve work efficiency of a typical BIM process. Of course, this doesn't mean that ABIMO isn't compatible with other BIM solutions. Although we strongly believe in the integrated modeling environment that ABIMO provides, we also understand that file importing and exporting is inevitable most of the time during a BIM process. This is why we've developed ABIMO to be fully compatible with other file formats that are conventionally used in the BIM industry. In fact, ABIMO is one of the most open platforms in terms of file compatibility, as it is capable of importing and exporting DWG and DXF files, as well as importing Collada files. It also fully supports the importing and exporting of the international standard IFC format, which makes ABIMO compatible with most of the BIM softwares in the industry. VirtualBuilders is extremely proud of what we've come up with, and both pleased and honored to have had an opportunity to show it in front of the Siemens AEC community. We believe that ABIMO will be one of the most powerfully efficient BIM solutions in the industry, as well as a competent partner for the other BIM solutions. And last but not least, we'd like to thank the AEC community for streaming in and watching this presentation. Please excuse me for not being able to answer questions live, but I am more than happy to receive any kind of questions or suggestions you have for us. You can contact us through the information below. We assure you that we will reply as soon as possible. Thank you.